Hi everyone. Today is the start of the track and field in the 2012 Olympics, and I must admit that I'm a fan of track and field. Um, so I got hold of some data here on this year's Olympics I'd like to share with you, and specifically we're going to use it to look at correlation. Okay, first of all, present the descriptive statistics. Gender, male and female, we've got height, weight data. We can see that this year's Olympics, London 2012 Olympics, there are 869 male participants, 718 women. Let's look at their height. So for the guys, shortest guy is 140 centimeters, tallest guy is 219, with the average height of about 6 foot, that's 1 meter 83, standard deviation of 10 centimeters. For the weight, you're varying from 49, God that's very slim, to a mammoth 218 kilograms. These are in kilograms. Average weight of an athlete is 80.5 kg. For women, minimum to maximum height, we've got 136 to 194 centimeters, for average of about 171 centimeters. And the weight, you're going from a very minuscule 30 kg to 108 kg. Okay, now we're going to use this to study the correlation between weight and height. So let us just close our eyes and think back to what correlation measures. Correlation is a number that measures the strength of linear relationship between two variables. Now, I'm going to focus here on the Pearson's correlation coefficient, which is what most of you are taught when you first see correlation. And in Pearson's, we're looking at the relationship between two quantitative variables. So for Pearson's correlation, I'll say again, the definition is it's a number that measures the strength of linear relationship between two quantitative variables. Now, that's a mouthful, so let's visualize it. How can we visualize correlation? We can visualize correlation in a scatter plot. So we've got two variables that we're interested in. Is there a linear relationship, and if so, how strong is it? Right, so what I've got here to show you from this Olympic data of the participants is the relationship between weight and height. And the green circles here represent the females and the blue the men. Is there a linear relationship between, for females, let's just look at the green dots, ignore the blue dots. Well, by that we're saying, can we fit a straight line? Does it look like that there's a reasonable straight line through there, as opposed to say no line at all, or some kind of curved line? Well, it looks like, look, if I trace this through, it looks like there's some kind of line like that. Okay. Similarly for the men, what does that mean? It means that if we're reading off the graph, it means that if we increase, say, height, what happens to the weight? That tends to increase as well, doesn't it? Okay. Now, question is the correlation between height and weight stronger for men, or is it stronger for women? Looking at the picture, it looks like the green dots are bunched closer together, right, and upward sloping. For the men, you see it's upward sloping as well, but as the height and the weight increases, there's more disparity. You can see these dots are away from the main clump, and you've got one way out here. That guy, whoever that's a bloke, that guy is very, very different to everyone else. So that guy has got a height of over 180 centimeters and a weight of over 200 kilograms. Wow. Well, so whatever sport he's participating in is probably not a speed sport. Probably it's a sport where weight is important. We'll find out who that person is later. Right, okay. So the question is, can I measure the strength of linear relationship between weight and height for each gender? Because we want to see say whether the relationship is stronger for men or women. Now this correlation, we can, but from the graph we can't, you can only kind of guess. It looks like men, okay? But I'm going to show you later that the picture here can be misleading. So from the picture it looks like men, but we can't really say from the dots how strong the relationship is. So we have a measure. So the correlation, if we find the correlation value, we can kind of judge, is it a strong linear relationship or is it a weak linear relationship or is there no linear relationship? Now bear in mind, this correlation takes the value, it's on a scale between -1 to +1. If it's at the extreme, if it's -1, it means that it's a perfect negative linear relationship. In other words, you can draw a straight line and it's a negative slope and it goes through all the dots. If it's positive +1, then that means it's a perfect positive correlation, and you can draw a straight upward sloping line through all the dots. So judging here, we can see that since height and weight increase together, there's we say it's a positive correlation. In other words, positive linear relationship. Now let's look at the correlation figures. Right, it doesn't matter what software I've got this from, we'll just look at the numbers. The key number is this one. So for men, the correlation between height and weight is 0.69. Alright, so that is higher than 0.5. It's quite strong, isn't it? Let's compare that to women. So for women, the correlation between height and weight is 0.68 about. So they're very similar. They're very similar. Now, however, when we're doing correlations, our correlation figures can be distorted by any unusual observations, which are not typical of the main mass of data. So this guy here, he is an outlier. Being that, it means it can distort the value of the correlation. So when we calculate the Pearson's correlation coefficient, we have to be watchful of outliers, because outliers can distort our value, so it could give you a wrong figure, a figure that will mislead you into thinking that there is a stronger relationship than there is, or a weaker relationship than there is. Actually, it will be weaker than it is if it's an outlier, isn't there? Okay, so what can we do? Well, what we can do is we can remove that guy and recalculate the correlation. So here's the correlation with that guy, the outlier guy, is 0.69. Once I remove that guy, that outlier, the correlation now has increased to 0.721. So it's increased as we would expect, because now the linear relationship can look stronger because it's less dispersed at the top. By at the top I mean for higher weight and higher weights or in higher height. See? If we look more carefully at this, we can see it's more evident in the guys that maybe for the smaller height and weight ratings, those data points are bunched closer together, but the people basically become more and more different as the height and weight increases. Can you see why? By the clump of data becomes more spread out. Okay, so around here as we're increasing height and weight, it becomes more spread, but down lower end it's more clumped together, so they're more similar. For people of lower weight and height, they're more similar, but as the height and weight increases, people become more different, so then the ratios of weight and height become a lot more different as well. Okay, to recap, correlation measures the strength of linear relationship between two variables, and for the Pearson's it measures we're looking at quantitative variables. The correlation takes the value between -1 to +1. If it's negative, it means it's a negative correlation. If it's a positive figure, it means a positive correlation. By positive, we mean that as one variable increases, the other one increases. Now the correlation we looked at was about 0.69 for men and women, but that was for all athletes. But how about if we try to break it down by sport? that might be interesting, because if we break it down by sport, we can look for sports where the correlation is higher than others. Where a sport has higher correlation, where high correlation, it means that those athletes are more similar in terms of proportion of weight and height, and that kind of suggests that the build of the athlete is important. Whereas for sports that which has a low correlation for weight and height, that suggests that the body build is not as important, or it could mean that that sport has various, maybe have various weight categories, and we've already seen that the heavier that an athlete becomes, it seems that the relationship between weight and height becomes more dispersed. Okay, so let's see what for men and women, what the highest correlations and lowest correlations are. Okay, so we start here with the males. Males archery correlation between weight and height is 0.6, so that's over half. Okay, let's just the athletes is higher, 0.7. Badminton, it matters more, it's 0.75. Basketball, that's quite high, that's very high. Look, 0.89, so we expect that. Well, yes, these lanky guys are of a similar build, aren't they? Beach volleyball, opposite, it's not as important, it's about 0.5. Boxing, well, that has weight categories, but still the correlation is high. So in other words, the proportion of weight and height is quite tied close together. Slalom, 0.77. Canoe sprint, 0.7-ish. BMX, 0.8. Mountain biking, 0.8. Cycling, road cycling, 0.7. Track cycling, 0.6. Diving, 0.8. That's quite high. Equestrian, doesn't matter as much. It's that's below half. Fencing, high is 0.8. Football or soccer is 0.69. Artistic gymnastics, 0.8. Trampoline, 0.888. Handball, 0.89. Hockey, 0.75. Judo, 0.6. Well, that's quite low, and doesn't surprise us, because in judo you've got various weight categories, and you've got over 100 kg. Well, 100 kg. Those the guys there can be really heavy, and then their relationship to the weight may not be as proportional as if to the athletes who had lower weight. Okay, pentathlon. Wow, that is 0.9. That's the highest one so far. The pentathlon is the sport where the guys have to do, where the athletes have to do compete in 5 sports. Rowing, about so that's quite close to 0.9 as well. That's quite high. That's very high. That's almost the same. Sailing, slightly lower, 0.7. Shooting, 0.4. Swimming, 0.8. Table tennis, look, that is pretty low. That's the lowest so far, 0.14. That suggests for table tennis that proportion of weight and height doesn't matter as much. Okay, taekwondo, 0.888. Tennis, 0.7. Triathlon, 0.76. Volleyball, 0.7. Water sport, 0.67. Weightlifting, 0.77. That's also got 0.77. Wrestling, I don't think that's started yet. I'm looking forward to seeing some wrestling. 0.89. Archery, that's low as well, but that makes sense because, well, actually all you need is a steady hand and a good eye. It doesn't really matter how big you are, does it? But there you are, 0.2, so that's kind of reflected. Proportion of weight and height is not tied in a linear fashion as high as the other sports we've seen, apart from table tennis. Athletics, that's a track and field, 0.6. Badminton, which I love badminton, that's 0.65. Oh, sorry, we've gone into women now all of a sudden. Alright, so let's stop. Let's go. Right, so wrestling was the last one. That was for the guys. So we'll conclude then that for the men, that the highest was correlation between height and weight was about 0.9. That was pentathlon. And for the lowest, it was table tennis, and that was came in at 0.14. Both are positive, meaning that if height increases, weight increases as well. Okay, is there kind of does this kind of pattern hold for women? Let's do the same. So archery for these are ladies now. 0.2, that is low. Athletics 0.6. Badminton 0.65. By the way, I'm reading this out in case you can't see the screen. Some of you will be interested in this if you're sports, if you're doing sports science at college. 0.8. The others of you will eventually get bored. But let's see. Beach volleyball 0.7. Boxing 0.67. Canoe slalom. Aha. Look, it says relation between height and weight is perfect. 1. But can you actually trust that? Well, look, it's based on only 2 people. So there's only 2 ladies participating in canoe slalom. That figure can be dubious. Canoe sprint 0.6. BMX, 3 women participating in that, positive 0.6. Mountain biking, oh look, that's negative. That's the first negative we've come across. That's based on 4 participants, 4 ladies participating in mountain biking. Well, that means that there may well be a lanky lady in there, tall and slender. Tall and slender, or fat and short, right? Opposites anyway, between height and weight. I think it's more likely to be tall and slender than fat and short. Okay. Women cycling, road cycling 0.771. Track 0.22. That's unusual, isn't it? They're not tied as close together for the 2 different types of cycling. Diving 0.85. Is that similar to the men's? Can't remember. 0.8 I think for the guys. Equestrian 0.68. Fencing 0.7. Soccer 0.7. Artistic gymnastics 0.9. Oh, 0.9. That is the highest so far. And there's 13 participants or ladies there. Rhythmic gymnastics, 14 ladies there. Wow, that is almost 0. That is unusual. 0.047. That's like almost pretty much 0. That's saying there's no relationship between height and weight there. So we'd imagine there could be a cloud of dots, not going up or not going down. Well, I should look out for those ladies on the when they start performing. Gymnastics trampoline 0.8. Handball 0.663, hockey 0.8, judo 0.7, pentathlon, well look at this, this is different to the men's results because for the men's it came out at 0.9, this has come in much lower, 0.333. However, we have to note that it's based on 5 participants here. Okay, the results are more reliable where you have a larger sample. Rowing 0.88, that's for 39 participants. Sailing 0.64. Shooting 0.65. Swimming 0.68. There's a lot of participants there, 74. Synchronized swimming, 17 teams, comes in about half. Table tennis, opposite to the guys, this one comes in because for the guys it was the lowest correlation, which came at 0.14. Here it's coming at 0.8. So for the ladies, the kind of proportion between weight and height is much more similar among the athletes. Taekwondo 0.69, tennis 0.66, triathlon 0.77, volleyball 0.6, water polo 0.67, weightlifting 0.69, wrestling 0.22, and that is low, and that wouldn't surprise us because in wrestling there are also, unless I'm mistaken, weight categories, And so as we said, we've seen before from the data that the proportion between weight and height is more loose when for higher weights and higher heights, basically meaning that people are more and more different. Okay, well, alright, so for the females, that was the end of it. So to summarize then, for the females, the highest correlation came in at 0.9, and that was a score of 0.9, and that was for artistic gymnastics. And the lowest one was for rhythmic gymnastics at 0.047. Okay, well, make of that what you will. That's I hope that's been a bit more entertaining for you in terms of learning about correlation. There's one more entertaining thing to do, and that is recall that there was an outlier earlier on. So who is the gentleman? Who is the gentleman that is the outlier? Over 180 in height and over 200 in weight. Well, before I show you the answer, maybe you can guess. Have a guess at what sport that person might be involved in. Okay, and here is the answer. It is the competitor from Guam, Ricardo Blas Jr. Is it? Comes in at 185 centimeters and a weight of 218 kg, and he is participating in the judo men's 100 kg. Well, I believe that the final was yesterday. Oh, I don't think I know what the result of that is. But there you go. You don't want to be up against him in the middle of the night. Hope you enjoyed that. My name's Phil, statisticsmentor.com.